This is physics required practical current voltage characteristics. This is investigating the current and voltage characteristics of circuit components. So we're going to have a look at what happens to the current through a component when the potential difference across it changes. So if we have a look at the equipment that we've got for the first part of the practical, where we're going to use a resistor. So we have a power pack, we have an ammeter, a voltmeter, a resistor, and a variable resistor. So we have the power pack set to the DC current, and we have got from the positive into the positive part of the ammeter. From the ammeter in series, we have it connected to the resistor, and the resistor is connected in series to the variable resistor. This is then connected to the negative part of the power supply. And the voltmeter we're going to place in parallel over the resistor. So we're going to use the voltmeter to read the potential difference across the resistor, and we're going to use the ammeter to read the current through the resistor. So we turn on our power supply and we take a reading from our ammeter and from our voltmeter. We're then going to move and adjust the variable resistor and take our new readings. We're going to do several of these so that we get a range. So next we're going to change the direction of the battery. So we're going to put the positive in the negative and negative in the positive. So in this case, the potential difference has also reversed. So the voltmeter and the ammeter should both be reading negative results. And again, we're going to adjust the variable resistor and keep on recording several results to get a range. So we've taken our readings for our resistor and we've plotted it in a graph with current against potential difference. And as you can see, this has produced a straight line which goes through the origin here. So the current through the resistor is directly proportional to the potential difference. In other words, a resistor is an ohmic conductor. Now if we change the direction of the potential difference, we still get a straight line passing through zero. Now one thing to point out with this is that if the resistor gets hot, then the graph won't look like this and we won't get a straight line. So it's really important when we're doing this practical not to leave the circuit connected too long, or the temperature of the resistor may increase. So for the second part of this practical, we've just replaced the resistor with a filament lamp. So we've got the same, we've got the power supply, ammeter, lamp and variable resistor all set up in series, and the voltmeter in parallel over the filament lamp. So we're going to do exactly the same, turning on the power and taking our readings from the ammeter and from the voltmeter, altering the variable resistor and taking a range of results. We're then going to change the supply from positive to negative, so we change our direction and again take a series of results. So again, we've plotted our results for the lamp in a graph of current against potential difference. Now in this case, we can see that we've got a different shape. It's not a straight line. So this indicates to us that current is not proportional to the potential difference in this case. Now the reason for this is that as the current increases, the temperature of the filament lamp increases. This increased temperature causes the resistance to increase. And you'll see that we get the same shape even when the direction of the potential difference has changed. So for the third part of the practical, we now have a diode in the circuit. And you'll see that we also have an extra resistor. Now the reason we have an extra resistor is because diodes are very easily damaged by high current. So the extra resistor will keep the current relatively low and protect the diode. We also keep the power very, very low. As the current is low, we need a very sensitive ammeter. So instead of the normal regular ammeter, here we've got a multimeter. So we've got a milliammeter. So again, we've got the power supply connected in series to the resistor, the milliammeter, the diode, and the variable resistor and back to the power, and we have the voltmeter in parallel over the diode. We're going to do exactly the same with this setup. Turn the power on, take our readings, alter the variable resistor and get a range of different results. We're then going to switch the power supply to run in reverse and again get a range of results. So when we plot our results for the diode, we get a graph that's shaped like this. So with a diode, we only get a current when the potential difference is around about 0.6, 0.7 volts. And as the potential difference increases beyond this point, we get a sharp increase in the current. So with the diode, there's no current when the potential difference is reversed. And that's because in the reverse direction, the diode has a high resistance.